Hello, today we're going to take a look at rational function graphs. And in particular, we're going to take a look at vertical and horizontal asymptotes. So there's quite a bit that we're going to cover today. So the first thing that we are going to do is we are going to take a look at some graphs here. Like, what exactly are these vertical asymptotes that we're talking about? So the first thing we're going to do, and you don't have to copy these down, we're just going to take a look at them, is we're going to take a look at a whole bunch of just rational functions. What do these look like? So we have this one here, we have two swoops. So if I scroll out, some of you guys might recognize some of these. Here's another one. Sometimes there's even three parts, so we can kind of zoom in, see we have 1, 2, and 3. And here's another one, 1, 2, and 3. So our goal, the first thing we're going to do is we are going to take a look at vertical asymptotes. And I guess we could start with our parent rational function. Why don't we take a look at that? Our parent function, which some of you guys might remember, is y equals 1 over x. And if we were to graph this one is one where we just have our two swoops. And our asymptotes, we have a vertical one. It never crosses the y-axis. So we say our vertical asymptote is at x equals 0. And then it never crosses the x-axis here. So our horizontal asymptote is at y equals 0. But as we can see, there's all sorts of changes that happen to this. So again, the first thing we're going to take a look at is see if we can figure out where are our vertical asymptotes. All right, so let's take a look back at our graphs here. So let's take a look at, I'm going to take a look at this first one. Where would you guys say that vertical line runs? So that up and down line. And I'm going to say, I'll type it in here. I'll make it blue. In asymptotes, we usually dash in. So we can see that that one is dashed in at -5. So I want you to take a look at our equation. We have x plus 5, and it's at -5, okay? Well, let's take a look at this next one. We have x and x minus 6. Well, here's another one here, and if we zoom in there, so it never crosses that dashed line here, our vertical, well, that's at 6. So that one's at x equals 6. Well, let's see if we can figure out what about this third one here. So this third one, it looks like there's two of them. And let's see if we can kind of zoom in. So it looks like there's one here. So x equals 2. Then there's another one over here. Let's see. Is that x equals 6? Oh, nope, it's not x equals 6. It crosses it. It must be 5. There, so it never crosses that. So even though there's three parts of the graph, there are these two vertical asymptotes. And so if we're looking at that, or looking at our equation right here, it's at 5 and 2. The other one was at, if we looked at this equation, it was at 6. And at this one, it was at -5. So some of you might be looking at this and saying it's in the denominator. It's what makes a 0? In the denominator. And that makes sense because you can't divide by 0. So if we took a look at one of ours here, so if we had 3 over x minus 2, our vertical asymptote would be at x equals 2. And again, It's a vertical, so we go over to x equals 2, and there would be a vertical line right there. So if we had another one here, let's say we had x over x minus 3. So our vertical asymptote would be at x equals 3. And if we were to graph it, we'd have our vertical right there. Now this last one, if we look at this last one on here, I'll take off these other ones. So this last problem, x squared plus 3x plus 1. And I'm going to change that to a 2. So if we look here, it looks like we have 1, maybe 2. So how do we decide? That equation, that equation isn't as easy to figure out. So if we looked at the equation, 2x divided by x squared plus 3x plus 2, we have to figure out where is our denominator 0. So where does x squared plus 3x plus 2, where does it equal 0? So we're going to have to factor that. So we're going to have to do a box and circle. So we have x squared, 3x, and 2. So our a times c, 1 times 2 is 2. Well, that one's pretty easy, 2 and 1. So 2x, 1x. So we have x times x plus 2 plus 1. So we just factored it into x plus 2 and x plus 1 equals 0. Okay, so we know where our asymptotes are. What makes those 0 is x equals negative 2 and x equals negative 1. And so now if we go to this, if I wanted to double check that, x equals 2, negative 2. Make this a different color so it shows up a little nicer. And let's see, x equals negative 1. We'll see it make this one green too so it shows up. Yeah, and that's where those two are at x equals 2 and x equals 1. So to find our vertical here, again, what makes a 0 in the denominator? So x minus 2 is positive 2, x minus 3 is positive 3, and then we had to factor it and solve. So the other type that we're going to look at today is sometimes there's these horizontal asymptotes as well. And when we take a look at up here, our horizontal one was the x-axis. So what's going to happen to it? Let's see, I'm going to open up some with horizontal and see if we can guess where those are. What if I just had 2x divided by x minus 1? Where would you guys say our horizontal is on here? So going straight across. So it's a height one. So y equals 2. Dash that up. So let's see, yep, it runs right along y equals 2. Okay, let's take a look at another one. Let's say we had y equals 3x squared divided by, say, x squared plus 2x plus 5. Whoa, this is kind of a crazy looking one. But let's see, it still seems to flatten out along something. So where is that happening? Let's try, is it y equals 2? If we zoom out here, I wonder if we can get closer. Is it y equals 3? Oh, that even looks closer. Let's zoom in. Yeah, that looks like where it is. Y equals 3. So if we take a look at these equations here, we had 2. We had 2x over x, 3x squared, 3x over x squared. So it kind of looks like it's that coefficient here. But I'm going to change something here. So what happens to this one here? If I took out that x on top, it It's no longer at 2. It's at y equals 0. Okay, and if I took out that other one here, took out that x on top, this one's going along the x-axis again. So one way to think about horizontal asymptotes is what happens as x goes to infinity and x goes to negative infinity. So for example, if we had y equals 2 over x minus 1, as this number gets really, really big, it's 2 over a huge number, which is really close to 0. Whereas if we had one that was like 3x squared over x squared plus 2x plus 5, if we start thinking I'm going to make this x number really, really big, the only thing that's going to matter is this huge number over x squared. Because in reality, 2x plus 5, those aren't that big. So this would go to 3x squared over x squared, which would go to 3. So one way you can think about it is x gets big. What does that number go to? Because some of them just won't matter. Some of you might notice there's a pattern here. If we look at the degree of the numerator and denominator. And there's 2 cases we're going to look at. If our denominator, the degree of the denominator is greater than the numerator, it's at y equals 0. If the degree of the numerator equals the denominator, it is the leading coefficient divided by the leading coefficient. So it's those numbers out in front. And if it's greater, if the numerator is greater, then it's what's called a slant. But we're only going to work at these 2 cases. So let's take a look at a couple more. If I had y equals x plus 1 over x squared plus 5x plus 2. So this is just x and x squared. So our denominator is greater than our numerator, so it's at y equals 0, because the big number's on the bottom. Let's say we had y equals 5 over x minus 1. Well, this is the only spot where there's an x, so it's like our top one is 0. So again, the denominator is greater than the numerator, so it's at y equals 0. If we had y equals x plus 5 over x minus 2, maybe I'll make it 2x minus 2, we'll notice they're the same degree, so the numerator equals the denominator, so it's x over 2x, and it's those leading coefficients, so it'd be at y equals 1/2. And if, let's take a look at one more. What if we had 3x squared plus 5 over 4x squared plus 6x plus 2? Again, we're just looking for the highest degree, so that's a 2 and a 2. So it's 3 equal to each other. The numerator equals the denominator. So we have 3x squared over 4x squared. So that's those leading coefficients, 3/4. So it's at a height of y equals 3/4.